Hello, I'm Chang-Ho. Today I'm going to give you some explanations on how to set up display calibration for the new MacBook Pros with macOS 12 monitoring system. Months ago, one of the viewers requested the information in English, so here it goes. Those who recently purchased MacBook Pros and also who are at least a little familiar with color management would have been surprised to find there is no monitor profile list in the display preference. So we will see what happened and what we can do about it. Before we get into the subject, I would like to introduce you to my book, Lectures on Color Management. This book explains pretty much everything from fundamentals of colorimetry, CIE colorimetry, what is XYZ, XYY, tri-stimulus value, CCT, CRI, LAB, LCH, and so on, and the concepts of ICC-based color management to actual monitor calibration, digital camera profiling, RGB CMYK printer profiling, how to use the profiles, of course, plus various applications for color professionals, for example, using Babel color softwares. You will find all the concepts and details that you may need to understand to practice color management successfully, whether you are a designer, a photographer, or a printer, or a color professional. Unfortunately, it is available only in Korean now. About display calibration, it is achieved with three main settings: white point, as you see it here, and luminance, and gamma. Whichever software you use, you need to choose the three settings to get a display condition proper for your needs. White point is the color of white of your display, which is expressed mainly either in color temperature Kelvin or in XY values, XY coordinates. Luminance is the brightness of white of your display, which is expressed in candela per square meter or simply in nit. Gamma is the input-output relation curve between input voltage and output physical brightness of the display, or simply the tone reproduction curve. For gamma, we mostly use 2.2 like this, but for white point and luminance, you may need some experience because you have to find right values for luminance and white point to match your working environment. In other words, the white and the brightness must match those of reference white paper under your working light. Especially for photographers or graphic designers whose output is mostly paper-based, the white of the display must look like a sheet of white paper, not a radiating light source. And display calibration eventually results in an ICC profile. And ICC profile has two parts in it: calibration curve and color profile. The calibration curve actually sets your display's white-gray balance, neutrality, gamma distribution. It's all about black and white. It doesn't directly apply to color. It also means that all color display is not accurate just because you calibrated the display. The color is calculated with the help of profile part based on the calibration curve, which includes the color gamut of the specific display, the actual color measurement data in device-independent color space, such as CIE LAB, and the profile info must be read and recognized by color-managed software. So, two conditions must be met for an accurate color display: the calibration curve must be loaded properly, and the profile information must be read by the graphics software like Adobe Photoshop, Lightroom, etc. So, what changed? Before macOS 12, we had always visited the display preference panel and chose desired display profile there and its calibration curve set in action instantly. But now it's gone. It's totally different. It looks different. There's no color tab, no display profile list either. There's only a list of presets. The preset is a set that combines 4 different factors of color: color gamut, luminance, white point, and gamma. There are 11 Apple presets like this, and in addition you can make presets of your own choice, of course. Now we need to talk a little about XDR, SDR, HDR, because here you see XDR. SDR is standard dynamic range, and it's just a normal display that we all know well. HDR is for high dynamic range, and it is a technology that captures a wide range of brightness, such as that is seen in nature, encodes it, and then plays back on display with a brightness that surpasses the standard limit of white level. For example, if a display's luminance is 200 candela per square meter or nit, nothing can be brighter than that in SDR. But in HDR, when the system recognizes the HDR content, it boosts the maximum brightness of the local area to such a level that it exceeds way over the normal limit, say 1000 candela per square meter, thus reproduces the brilliance of the original scene. That is the HDR. And Apple calls it XDR for extreme dynamic range, with a max brightness up to 1600 candela per square meter or nit. Okay, then how can we properly calibrate the new Liquid Retina display, or can we? Yes, you can, but ironically enough, it is not recommended because you will get a wrong result, a wrong white point, a wrong luminance, a wrong color gamut. This is the result of a calibration I've done. This is the target, this is what I wanted, and this is what has what's been achieved. My target was X 0.319 and Y 0.345, and the achieved values are like this. It's all totally wrong. Luminous, wrong. Color gamut is wrong. The outside mesh gamut is the native P3 color space, and the inner, this one solid body, is the resulting color gamut of the ICC profile that was created during the calibration. And as you see, there is a lot of difference. That's why. The main reason is that the Apple system resists and it does not yield to the calibration software's control. The video curve should be set free back to its native state without any control before the calibration process starts, but it is not the case with this system. As of now, Apple allows you to use only specific high-end hardware and software, which are not available even for most color professionals. To get an excellent match between monitor and print, you must first have a good quality light in your room. There are 3 conditions to consider. First, CRI, color render index RA, should be over 95, and CCT, correlated color temperature, should be between 5000 Kelvin and 6500 Kelvin. Somewhere between 5100 and 5500 Kelvin is the best because it is closest to the natural sunlight, neither warm nor cool. Illuminance, or the incident brightness at your workspace, should be between 600 and 1200 lux. 600 is the minimum. The lighting is very important because if you are a photographer or a designer, you must be able to compare the output with the display, and the color appearance of that output is heavily affected by the light. This is the spectrum of my desk light, and it's a combination of an LED light and fluorescent light. And this peak comes from the fluorescent lamp, and this blue peak comes from the LED light. And the combined spectrum looks like this. And as you see here, white point is about 5110 Kelvin. In terms of XY coordinates, it is 0.342x. Y is 0.356. And illuminance is about 750 lux. And the color quality, color render index, RA, is 97, very high. You are supposed to have something like this. It's highly recommended. Remember, there are 4 elements to consider: white point, illuminance, gamma, and color gamut. And now you have roughly 2 options to go for. First, use Apple XDR preset with auto brightness and true tone functions on. Then, with this setup, you can enjoy the brilliant HDR contents, of course, proper brightness and white balance for your environment you are in, and of course the widest color gamut available. It is not numerically precise, but accurate enough for most users. So this is my first recommendation. And what about the other Apple presets like this? They are called so-called industry standard reference presets. They have all fixed parameters. For example, photography preset has P3 color gamut, gamma 2.2, white point T65, 6500 Kelvin, and luminance about 180 candela per square meter. Design and print preset has D50 white point instead, and digital cinema P3 DCI preset has gamma 2.6, very dark luminance about 50 candela per square meter, P3 color gamut, and DCI white point. You cannot modify them because if you can, they do not conform to the specifications. This sounds pretty technical and of course maybe useful, but not necessarily. At least when it comes to photography and design presets, they are designed to be used under 32 lux and 64 lux respectively. It's very dark. Who would work under the condition while comparing output with display? It's nonsense. Because these 2 areas are always paper-based, the display must match the output. The output is seen under a lighting, and no lighting available is visually matched with real D50 or real D65 white point. That is why. So if you use either of the presets, you will not have the best match between what you see on display and the print you have. The brightness will be different, and the white-gray balance will be different. For the second option, you must understand what values of XY and candela per square meter you want to use. XY values, as you see here, XY values come from the CIE 1931 XYY chromaticity diagram, and it is similar to the hue and temperature settings of Adobe Lightroom. The X-axis controls blue and yellow tint, and this Y-axis controls green and magenta tint. Larger X means yellower, warmer, and vice versa, and larger Y means greener, and vice versa. By pinpointing the XY coordinates, you can get the precise color of white. Then how can we do that? If you have a bit of colorimetric knowledge, you can calibrate the new MacBook Pro display without even using a calibration hardware. Just type in the values you want, it's done. So go to Preset, click, and select Customize Preset, and plus here, and then you have something like this, and here you type in values. Here you can type in XY values, luminance values, color gamut, and gamma you want. Of course, within a certain limit. Then it will do the rest automatically because it was factory calibrated individually. It means the system knows what your specific display is like. Of course, there is a slight level of inaccuracy, as I said, but again, no problem for most users. Of the four factors, color gamut and gamma is easy to choose. You will want the widest gamut possible, so P3 should be the choice, which is the native color space of the display. For gamma, 2.2 is the choice. And then what about luminance and white point? As I said, your goal is to get a nice visual match. This is very important, visual match between the white and gray on the display and the physical white and gray you have under the specific lighting you are using. In my case, the target luminance is about 185 candela per square meter, and white point is X 0.335 and Y 0.345. Regarding luminance, this is how you calculate the luminance candela per square meter from a measured illuminance lux, if available. The incident brightness, roughly 5 inches above the surface of my working desk, is, as you saw, is 750 lux. Then multiply the square root of the value by 6.8. The answer is 186. So 185 candela per square meter is the target value for me. When it comes to this white point, there is no convenient way. You might think if you can measure the XY values of your light because you have something like i1 Pro spectrophotometer, you can safely use them for white point target, but it doesn't work like that. If you do so, you will always get a warmer white point on display. So you must tweak a little bit, mostly smaller XY values, meaning slightly cooler white, say 300 Kelvin cooler, but it varies depending on the type of lighting. That's why I said there is no convenient way to get the right values. you need to navigate through XY numbers while understanding what they do in effect. In my case, the actual XY values of my workspace were X 0.342 and Y 0.356, which is about 1500 Kelvin, whereas my target point now is 5390 Kelvin. That's about 300 Kelvin difference. So there is minus 0.007 difference for X and minus 0.011 difference for Y. My suggestion for starting point is like this. If you are using ordinary 3-band fluorescent lamp that looks pretty white, neither warm nor cool, start from X 0.319, Y 0.345. If you are using some kind of D50 standard lighting, start from X 0.333, Y 0.346. Regarding white points, everybody seems to be talking only about D50 or D65, but please remember you cannot get an excellent monitor to print match whichever white point you choose. You must pinpoint it with XY coordinates. Okay? This is how you calibrate your new display. By the way, you need to understand that the factory profile for your display is located in, as you see here, Library, Color Sync, Profiles, and Displays folder. This is the one. It has a very long name, and also you need to understand the actual name as read by the graphic software is just display. For example, go to Photoshop and edit color settings. Click this one, RGB, and you will see monitor RGB. And by that, you see a name, a display. This is the internal name of the specific color profile of your display. So you must see just display, not the long number or anything other than that. Okay? So here you can find the profile name. You need to make sure the display profile is correctly recognized by color managed graphic softwares. And also I missed here you go to color sync utility and displays color LCD and factory profile. This is the one you saw, right? And current profile should be the same. This is the factory profile, and this current profile is what is transmitted to graphic softwares. So you must see the same thing here, and now you see display name in the color setting of the graphic softwares like Photoshop. Okay, so summing up, the goal is to get a nice visual match between the display and the output. Of course, the color on display itself should be accurate. The easier way is to use Apple XDR preset with True Tone and Auto Brightness control checked. The more accurate and sophisticated way is to pinpoint white point in XY coordinates and luminance in candela per square meter. You can do that by typing them in Customize Preset menu. Make sure that the profile name display should be recognized by graphics softwares by going to Photoshop, Edit, Color Settings, Working Space RGB, Monitor RGB. So this is how you properly calibrate the new Liquid Retina XDR displays. I hope this is of help for anyone who uses new MacBook Pros. Thank you.